Again, welcome back to Java programming language. These lectures cover the selection statements, and we are going to focus on logical operators. Logical operators allow us to combine two or more conditions. So in our previous lectures, we went through relational operators and also how to implement the if-else, and multi-if-else statements. In this session, we're going to learn how to use the logical operators and also how to implement the switch statements and also the conditional expressions. So first, we start with the logical operators. In almost every programming language, we have three basic logical operators, which is not, and or. We also have what we call the exclusive or, which is logical exclusion. But in this, most of the operators we are going to use is the first three operators. So we'll go through what is a not operator, which is logical negation, and also the and operator. In Java, we use the symbol $, double, 2% to represent and also two vertical lines to represent all. So let's see an example here. We are going to use the truth table for each of the operators. So here we start with the truth table for operator not. Again, exclamation means not operator. So it's very straightforward. If we have true, not true is false. False, not false is true. So for example, we have an input of P. So if P is true, not P will be false. If P is false, not P will be true. So normally we call the not operator as a unary operator. It takes only one, again, operand. So example is given here. We are assuming age is 24, weight is 140. So if we say not age greater than 18, age is 24, so it's greater than 18. So not age greater than 18 will give us false. Because again, age is greater than 18 is true. The next one we have weight. The actual weight is 140. Now here we say not weight is equal to 150. Yeah, that will be true because the actual weight is 140. It's not 150. So not weight equal to 150 is true because the weight is equal to 140. Again, here it's supposed to be 140. It's true. So weight equal to 150 is false. So not false becomes true. So again, the not operator, we use the term negate or complement. True, not true is false. False, not false is true. So if age is 24, and we say not age is 24, then it will be false because age is 24. So not, age is 24, which is true. So not true will give us false. Now let's go to the AND operator. AND operator is almost like the product. So AND operator is a binary operator because you have to take two operands. For example, here we have P1 and P2. Now what we're going to say is that if P1 is false and P2 is false, then P1 and P2 will also be false. If P1 is false and P2 is true, P1 and P2 also will be false. If P1 is true and P2 is false, P1 and P2 will be false. And if P1 is true and P2 is true, then P1 and P2 will be true. So here we are going to say that we only get apple true if both conditions are true. So it's kind of like a product. So if one condition is false or both conditions are false, the output will be false. If both conditions are true, then the output will be true. So example given here is we have age is less than or equal to 18 and age is less than 140. Here we say it's false because both conditions are false. Age is 24. 24 is greater than 18. 18. But here we say 24 is less than or equal to 18. So that is false. And weight, 140 is less than 140. That's also false. So both condition is false. Now here we say if age is greater than 18, which is true because age is 24. So 24 is greater than 18. and the weight 140. 140 is greater than 140. No, that is false. Now, because one condition is false, the output also will be false. The next one, we have age greater than 18, which is true because 24 is greater than 18. And 140 greater than or equal to 140. Okay, that's true also. So now, since both conditions are true, the output is true. Another age greater than 18 and weight is greater than or equal to 140, again, is true. Now, with the or, it's kind of opposite of n. If there's only false, if both conditions are false. So, for example, P1 is false, P2 is false, the output is false. But P1 is false, P2 is true, the output is true. P1 is true, P2 is false, the output is true. Both are true, the output is true. So we only get false when both conditions are false. Otherwise, we get true. With the AND operator, we only get true when both inputs are true. Otherwise, the rest are false. But with OR operator, we only get false when both are false. Otherwise, the rest are true. So example given here, we have age is 24 again. The weight is 140. Is 24 greater than 34? No, so that is false. Is 140 less than or equal to 140? True, because weight is equal to 140. 140 is less than or equal to 140. So since one condition is true, the output also will be true. Now, is 24 greater than 40? Yes, true. So technically, then the output will be true. If only one condition is true, then automatically the output will be true. Then this will be our exclusive. So here we said that if we have P1 and P2, if both of them are the same, our output is false. So P1 is false, P2 is false, the output is false. P1 is true, P2 is true, the output is false. If one of them is true and one of them is false, then the output is true. And normally we use the term exclusive OR for this. So here, for example, we have age is 24 again, the weight is 140. So age greater than 34, exclusive OR, age greater than 140. If age is 24 greater than 24 is false, it's 140 greater than 140 is false. So since both of them are false, our output will be true. As we said, the output will be false. So for example, if both are false, the output is false. If one of them is true and one is false, the output is true. So again, 24 greater than 34, no, false. 140 greater than 140, no, it's false. So here we say it's true. Again, that's supposed to be false. So age is false, weight is false. So our output again is false. Now, next one we have 34 greater than 34, that's false. Is 140 greater than or equal to 140? Yeah, that is true. So the output will be true then. One of them is false, one is true, the output is true. Here is 24 greater than 14 years. Is 140 greater? No, so the output again will be true. So now let's see some example. Here we have a program that will check whether a number is divisible by 2 and 3, whether the number also is divisible by 2 or 3, and also whether the number is divisible by 2 or 3, but not both. So this means we have more than one condition. So we have to use again a logical operator. So again, here we import our scanner class to get an input. We have our main class, and also we have our main method. We ask a user to enter. Actually, here we are using the random operator, and we are going to get a number. So this will generate a 2 single digits. for us. A number again between 0 to 9, a single digit will be generated for number 1 and number 2. And here we say that if number 1 is less than number 2, we want to swap the numbers because we want to get positive results. So if number 1 is less than number 2, we assign number 1 to temp, and we assign number 2 to number 1, and we assign temp to number 2. So what we did is that we swipe the numbers. 2 go to 1, 1 go to 2. Then next, we prompt the student to answer question. Here we got 2 numbers, and we ask the user to enter the correct answer. Then after the user entered the answer, we are going to grade the answer and display the result. So here we say if number 1 minus number 2 equal to the answer, then the student have it correct because again, student entered the answer here. We ask the user the number we generated minus the second number. What is the answer? The user entered it here. Now we are checking if the number 1 minus number 2 is equal to the answer. If it's correct, then if it's not correct, then we say it's wrong. Then we get the output correct answer. So that would be the example here. But again, here we didn't use the logical, but we're going to see an example for the logical operators now. So this will be the example for the logical operators. Here you can see that we have 2 conditions. We are checking if number modulus 2 equal to 0 and number modulus 3 equal to 0, which means we want to know if the number we enter is divisible by 2 and also divisible by 3. We know number modulus 3 equal to 0 means if I divide the number by 3, the remainder will be 0. So that's what we are checking. So we can use this means n operator. For example, 6 will be correct. 6 modulus 2 will give me 0, 6 modulus 3 will give me 0. But if I use 9, 9 is wrong because 9 modulus 2 is not 0, but 9 modulus 3 is 0. But when we look at the next example here, we are checking the number modulus 2 equal to 0 or the number modulus 3 equal to 0. So in this case, 9 will work because it's either one condition. So 9 modulus 3 is 0, so that's good. Then we have the exclusive also, which means we only get true if one is false and one is true. So now let's see the example for the logical operators here now. This example, actually, this is the same example again. I'm missing that. I think it should be in the next slide. Okay, so we may see that code in the next slide. So next is how to use the switch statement. Now, with the switch statement, it's the same as what we did a multi-if-else statement. In the multi-if-else statement, and we said that we have more than 2 conditions. So same thing. Let's say that this status is a variable. This variable can have a value 0, 1, 2, 3. So if the value is 0, then it's going to compute the taxes for single filers and it will break. If the status is 1, then it's going to do for married, then break. The break will make it possible so that we don't test more than one condition. If one condition is true, then that's it. We don't test no more. So for example, if the status is 0, we compute taxes for single filers, then we break. But if it's false, then we move to case 1. If it's false, we check case 2, etc. So this is how it works, the flow. So status 0, if it's true and we work on it, we have to break. If it's false, then we move to the second, check status 1. If it's false, we check status 2. If status 2 is true, then we do the work, then we break. So we can't go to status 3 or default. Now, default is last option. So if all our conditions are false, then the last option again will execute. So this is the example. Again, we have a switch. The switch expression is given, and we say the value can be 1, then we do something, we break. If the value is 2, we do something and break until the default. Again, we're going to solve a problem actually in the lab work. In the lab work, we're going to see a problem using both the logical operators and the switch statements. So this is the switch expression. Always it must be an interval. It must be an integer. So for example, if I'm doing the grading, I rather use the multi-if else, which means I'm going to say if the score is between 90 to 100 is A, between 80 to 89 is B. When you are using a case, it's better to have a very single value. What I mean, for example, we say that if the score is 100, A, 90, A, 81, B. So it's more or less, we don't use, so it should be a whole number always. So we have case 2, etc. Those will be the values up to case n. It can be any amount of cases. So the keyword break, as we said, is an optional, but it's very important. Here we say that, but it should be used at the end of each case in order to terminate the remainder of the switch statement. So if we don't have the break, if case value 1 is true, and we execute the statement 1, we're still going to test the value 2. So if we don't need to test it, then we have to break. And that's what we are saying here. Now, if all the conditions are false, then default will execute. So default is the last option. So this is example given. Suppose we have the day is 2. Now, case 1 will not work, but it will match case 2, and we do whatever we want to do. But it will go through case 3, case 4, case 5, and this is where you find the break. But if we have break after case 1, then we just end right there. So let's see this example here. This is a Chinese Zodiac program. Here they give us some years in animals, dog, pig, rat, etc. But let's see. And also from the question, we can see what each value represents. So 0 represents monkey, 1 represents rooster, 2 is dog, etc. So this would be a perfect program to use the switch statements. We're going to have a value from case 0, case 11. Then we have the default in case a user entered different value between 0 to 11. So let's see this code here. So again, here we have our scanner class to get our input. This is our input object again, the same method. So now we ask the user to enter the year. The user entered the year, then the year modulus 12. Anytime we divide a value by 12, the possible remainder is between 0 to 11. So year modulus 12 means if the remainder is 0, then we print monkey, we break. Very important. Then if the remainder is 1, we are going to print only rooster, then we break. If the remainder is 10, we are going to print horse, then we break. So again, this is just a very toy program to get the idea about how the switch syntax work. So we start with the keyword switch, then our condition to check. As we said, the condition should give us a specific value, like here 0, 1, 2, not between interval like between 90 to 100 or between 50 to 60. It should be specific value 0, 1, 2. Otherwise, if it's interval, then it's good to use the multiple if-else statements. Okay, so okay, this is it. Okay, so we're almost done. And this is the example again. So the next is the conditional operators. So this is the program we went through right now. Conditional operators also, for example, instead of writing if s is greater than 0, assign 1 to y, else -1 to y, which means if the condition is true, y will be 1. If the condition is false, y will be -1. Now we can write it in one line. So here we say if s is greater than 0, question mark. After the question mark, we have the true statement. So here we assign 1 to y. After the column will be if the condition is false. So this is called a conditional operator. So you have your Boolean expression. The question mark expression 1 means if the Boolean expression is true, expression 1 will execute. If the Boolean expression is false, expression 2 will execute. And there's a question mark and a column between them. So this example given to us, if non-modulus 2 equal to 0, then we print that it's even number or it's odd number. Well, we can write this using conditional operator. If the number modulus 2 equal to 0, then we are going to print the number is even. Then we have the column. If it's false, then we say the number is odd. And that's again the syntax, the Boolean expression question mark, true statement, column, the false statement. One thing also we should know is the operator precedency when we are doing all these operations. So we have the increment and decrement operator. Then we have the unary operators plus and minus. Typecasting comes, then not. Then we have multiplication, division, and remainder. Then, of course, the addition and subtraction. Then the relational operators, equality, exclusive, or, and, or then assignment operator is the lowest. Again, as we keep solving problems, hopefully we shall get used to all these operators. So here we say also sometimes if the two, for example, here we have multiplication, division, and remainder. If they are all in the same level, then the expression will start from left to right. So here we say expression in the parentheses is evaluated first, always parentheses first. Then parentheses can be nested, in which the case, the expression in the inner parentheses is executed first. Now, when evaluating an expression without a parenthesis, then the operators are applied according to the precedency rule and also associative rule, either from left to right, if they are all in the same level. If operators with the same precedence are next to each other, then the associativeness determines the order of evaluation. All binary operators, set assignment operators, are left associative. Most of the time, again, if they are all in the same level, we do the operation from left to right. What we mean is that if we have multiplication and division, we know multiplication and division the same level. But if multiplication comes first from left, then it will be executed first before division. So this example again, inner parentheses will be executed first. So here A minus B will give us the answer. The answer we get, we add it to C. So always parentheses first before the order of operations. This is another example given. We can see this expression 4 plus 3 first. Then when we come here, we have two multiplication. They are the same level. So we do the left first. Then we do the right. Then next, the plus comes and minus are in the same level, but from left to right. So we do plus first before minus. Then as we say, relational operators are always last with the assignment. So after arithmetic operation, we have relational, then equality, not equality, etc. So that will be the conclusion of this lecture. Again, the main focus of these lectures is to understand the concept or the syntax of logical operators, how to use the switch statements, etc. We didn't do much work here, lab work, So our next lectures, which will be a lab work, we will solve at least 2 questions. Thank you.